Okay, so on to question 3. We've got quite a big bit of text at the top, and it says, we've got an aircraft. Passengers sitting on the aircraft can push a button which calls over an air hostess or whatever it is, alright? So that's like the main sequence, so it's just sitting there waiting until someone presses it, alright? Then it says that it can be overridden, like an interrupt can be overridden by the captain pushing it in an emergency. Right, so say it's running through this main sequence, but the captain's got an emergency, he pushes the button, it stops doing what it's doing, goes over, goes through what the captain wants it to do, and then it'll come back, right? So the first bit, it says, the interrupt vector is address 04, so that's just the line in the code at which it is the interrupt's going to be. Alright, it says, write the instruction so that the address it will jump to that service routine, alright? So this is where it's going to go. All we need to write is, we want it, the name of the interrupt is called captain, so when the captain pushes it, what we want to do, these are easy, is use a go to statement, go to captain, alright? Don't use call captain, because some of you might think, oh yeah, we'll use call captain. You don't use call, use the go to, alright? Next part of the question, quite a lot, worth quite a lot of marks. It gives us a couple of bullet points. It says, this is the interrupt. So after we push this, after the captain pushed the button, this is what we're going to. We're going to this interrupt service routine. It says it makes use of a 0.5 second delay called half, alright? So that's another interrupt that's going to be over here somewhere, which we can call. Alright, the buzzer controls the buzzer, which is bit 1 of port B, and monitors a switch at port A, bit 1. Alright? So, we're given this is what we're given to start off with. First of all, we see captain, move working to the file, work temp. This line is, what it's doing is, it's saying, alright, we're running through that main sequence, alright, and now the captain's pushed his buzzer. So we need to go over to this interrupt. But what it's doing is storing where we're at in the main sequence, storing it over here temporarily, storing this over here temporarily until it runs through the interrupt, and after it's done that, it'll come back to this main sequence and it will reload where we was from here, reload it back to keep running through in its main sequence, right? So that's that first bit. Alright, next bit it says loop, bit set file, and then here it's saying these semicolons are telling us that's just telling us what it wants us to do, alright? It's saying switch on the buzzer. So we know that buzzer is bit 1 of port B. So we can just go bit set file, port B, bit 1. Alright, so bit set file, so we have to put the 1 at the end because it's bit 1. Alright, if it was controls the buzzer at bit 3 of port B, it would be port B, bit number 3. Alright? Then it says waits half a second. We know that we've got this half a second delay called half. It's already got the call written for us. All we have to do is call half. Okay. Next bit, it says switch off the buzzer. Alright? So we've bit set file, the port B bit 1. All we need to do now is clear that file. It's got a bit clear file written for already. So bit clear file, port B, bit 1. And then it wants us to wait half a second again. We call that half. Call half again, which was written up there. Next line, this is giving us a hint. It says, has the reset been switched? We're given a load of different commands that we can use, and out of them you should be able to pick up, if you're getting used to them, we should be able to pick up, if it's saying, has the reset been pressed, we're thinking we're going to need to test something, to test has it been pressed or has it not been pressed. So that's when we come in with our bit test file, skip if set. Bit test file, skip if set. So we want to check, has the reset been switched, alright? The reset, we said before, is port A, bit 0, alright? So we have it has been pressed, we're going to go, has port A, bit 0 been pressed? So bit set file, port A, bit 0. So port A, bit 0 has been pressed, alright? If it's not been pressed, go back to it and switch on the buzzer. So we're saying, it's going to test this file, if it is set, then it will go on. If it has been set, it will jump down here. If not, it'll go on to this one, and it wants us to go back to switch on the buzzer. So there we need a go-to statement, loop. Alright, so that's going to take us, if it's not set, it's going to go up to this loop, it'll keep going through, it'll keep doing this, going through this sequence, testing this bit, until, as soon as this isn't set, it's going to skip if it's set, so it's when this bit gets set, we're going to jump over that go-to loop, so it's going to stop going around in that little loop, it's going to jump over down to here. And at this point, we want to, this means, oh yeah, it's all finished now, our thing's finished, so we want to go back to the main sequence. So we need to get where we was, this is where we had stored it temporarily, alright, we need to get that back and carry on running through it. So what we need to do is, we need to move working to the file, work temp. Alright, so it starts off like this. So we've got to come and get this back, alright? So this is temporarily stored over here. We want to put that into the working register. And that we do by putting a 0, alright? You've got stuff at the front of your paper, and it tells you in there, if you read through that and take a little bit of time before you go into the exam, just looking through that, that's why we put that 0 there, alright? And then at the end of it all, we always write rectify, like that, alright? So that's that. It's quite hard to understand, but after you've done a couple of them, get used to it, it's alright. Last part of the question says, basically what and why is the purpose of this move work into the file. What's the purpose of that? I've said it quite a few times now. What it is it's temporarily going to store the working register until you've run through the interrupt service, and at the end it will put it back into the working register so you can carry on. So we write moves the content of the working register to a temporary store, and whilst the interrupt takes place. I'll just see what the mark scheme writes. They says it saves the contents of the working register when entering the interrupt, and the working register may be used. And yeah, so it does that. So yeah, it saves it because in this interrupt we might be using the working register, so we change content. So yeah, that's your answer.